All right, so right about now, you're getting your test released to you. So you have that with you, as well as this video is going to walk you through the answers and the explanations to each of these problems. If you took a paper test, you can come pick that up if you don't have that already. Okay, so yours is going to be in probably in a different order, so you'll have to pause the video and find your questions. All right, question number one on my screen here. I just want to point out to you. So if you go into Canvas, and this problem is right out of the first worksheet, which is right there, review worksheet. All our worksheets come with answers. All right, so let's go back here. Chemical reactions can be concisely represented by. So there it is, the first sentence. It's just copied and pasted from your worksheet. All right, and so the answer is at the end of the worksheet. Chemical reactions can be concisely represented by chemical equations. Hopefully nobody got that wrong, because that's what we've been doing for quite some time here. Chemical reactions written as chemical equations. All right, so if we move on and down that worksheet, all right, it's actually the very next sentence. I don't know if you can, let me zoom in on this. There we go. All right, the substance that undergoes a chemical change are the, all right, and again, the answers are at the end of the worksheet. So those are going to be the reactants that undergo change. And the things that are produced are called the products. All right, so there's your answer to that question. Let's keep moving on. All right, the symbol, that's the Greek symbol delta, capital delta. All right, so let's see, is that on here? Ah, there it is. Number 14, the symbol. These are all also in our class notes, by the way, which is also on Canvas. All right, and this is always true. The answer again at the end of the worksheet. All right, heat is supplied to the reaction. Heat is supplied to the reaction, so there's your answer to that one. Okay. And then these always true, sometimes true, never true. They're usually from these worksheets, and they may be changed sometimes. Oh, it's number 16. All right. Skeletal equation is not balanced, and if you go to I'll show you that in here. Number 16 is sometimes true. All right, so this is sometimes true. So let me give you an example. I think if I think of one. Which a skeleton equation can be balanced. Okay, like here's an example. Hydrogen gas, hydrogen, what am I doing? H2 plus O2 leads to H2O2, which is hydrogen peroxide. Now this is already balanced, but this is also our skeletal equation, which is just the bare bones equation without it being balanced. All right, so that is sometimes true. Usually not, or oftentimes not, but it is sometimes true. Okay, moving on. Calcium carbide pellet. So we've seen this a couple times already. This is exactly what we did in our lab at station number 1. In fact, I think this is just copied from your lab. And so there, your answer is there if you did your lab. It's the same question. Write the balanced equation for the complete combustion of acetylene, which is also known as, it gives you the formula there. So that's the same question here. Write the balanced equation for the complete combustion of acetylene. It's right back to the previous worksheet that we is actually there. So question number 24. Let me see if I can zoom in on this. Question number 24. Acetylene gas burns, right, to form carbon dioxide and water. Right. The question is the same. Write the balanced equation. All right. So the answer is right there right on your worksheet. So we can just copy that over. Can I do that here? Screenshot. screenshot. All right, let's go back to your test. There's your answer. Okay, or you can go back to your worksheet and the answer's there as well. All right, so a couple students asked, like, what does this calcium carbide have to anything? It doesn't, this was a distractor. So I'm sorry, you're gonna have to learn how to eliminate certain distractors. You're gonna see them. All right, so calcium carbide, those are the pellets we put into our flask that we filled up with 60 to 7 mils of water, if you remember that station one, and then that flask exploded or that bottle exploded, whatever you use. Okay, so that was one reaction, but that formed the acetylene. This question is asking you, we brought a flame to it, and that's what caused that explosion. This question is asking you to describe that reaction. All right, so this is reaction number one. And this is reaction number two, right? So this was just a distractor. You could have just ignored it, all right? Really, the question is, write the combustion of acetylene. So this is what you're answering, and the answer is here. All right, let me just do a little more. When you're burning or combusting a hydrocarbon, you need to add O2. All right, and a complete combustion, right, which means it's a clean burn. Everything's going to turn into carbon dioxide and water. Okay, so let's see. Now we're in section 2 worksheet. So this one is section 2 worksheet. Okay, I'm going to go down to the last question. Zoom in on this one. So this one is actually used for one of your open-ended questions, but if you go down to the answer, all right, it does tell you for every double replacement reaction to occur, one of the products must be a solid, which we call a precipitate, liquid, oftentimes water, or gas. Right, and that's also in your notes. So the answer is double replacement reactions. All right, the products must be solid, liquid, or a gas. All right. Okay, so this was just that same question here on this worksheet. All right, lithium phosphate, zinc nitrate. So let's just start with this. It wasn't the same exact question, but I'm going to I'll just do this one. I'll work this out with you. So enough copy and pasting, because this is probably the lowest scoring question on average wise. So I'll go over this with you. All right, so we want to first write the equation, lithium phosphate. Okay, so lithium is Li, phosphate is on your reference sheet. It's a polyatomic ion, PO4 with a 3 negative charge. Lithium has a 1 positive charge because it's in the first column. That's not the reason why, but you can see that it's in the first column of your periodic table, and that will give you the charges of the metals. All right, we're going to crisscross these charges. Right, the one we don't have to write. Right, so that's how we get the formula unit. Now it's not proper to leave those charges there. All right, so we got our formula unit. All right, we'll indicate that that's in solution by putting AQ there because it's a solution. All right, and zinc nitrate. All right, so I'm going to leave a little space here because I might have to balance the zinc. That's also on your reference sheet. That's a 2 positive. Actually, let me do that later. All right, nitrate is a polyatomic ion. All right, it's NO3 with a 1 negative charge. Zinc has a 2 positive charge, so we need to crisscross these numbers to get the formula of this compound. Right, but again, we're going to erase these charges after we've used them to determine the formula. Now this 2 has got to go outside of parentheses, otherwise it looks like 32, all right, or something weird. All right, that's also in solution. All right, so this is our reactants. Okay, now we need to, we need to recognize this is in the format AB plus CD, or whatever letters we use. I think in class we use the XY. Right, so this is your double replacement reaction. We need to switch the cations, all right, to get the products. All right, so let's do that. let's switch lithium and zinc. They're going to switch partners. All right, so if we do that, all right, lithium is now going to end up with nitrate. All right, and so this is one positive, this is one negative. They're going to cancel out. So that is our formula unit. All right, now you look at your solubility rules, which is on your reference sheet, and you'll see that all nitrates are soluble. So and that means it's going to dissolve in water. Okay, now if we switch the other ones, zinc is now going to be with phosphate. Right, so now PO4, phosphate, that has a 3 negative charge, zinc has a 2 positive charge. We're going to crisscross those. They're not going to cancel, so when you crisscross, the formula unit will be, all right, the 3 will go down there, and then we need a parenthesis here because then it looks like 42 without that. All right, so phosphate, if you look on your solubility rules on your reference sheet, all right, they're generally not soluble, so this is going to be a precipitate. Okay, so let's balance this. All right, to balance this, we see there's 3 lithiums on the left, only 1. So we're gonna add a 3. We can only balance. Let me pick a darker color. We can only balance equations by manipulating the coefficients. Okay, now we have 3 lithiums on the right side. We need to update the nitrates. Okay, we have 3 of those. All right, this one. I better show my work. This one's usually these things you can oftentimes you can get away without showing your work. Let's just show our work here. All right, lithium. I have a phosphate. I have a zinc, and I have a nitrate. So in that same order, on the other side, it has to appear, right? Because conservation of mass says things are not going to just disappear, right? So I know I'm going to have the same stuff. I'm going to put it side by side so I can compare to what I have on the left side. All right, I've got 3 lithiums, 1 phosphate, 1 zinc, 2 nitrates. On the right side, I have 1 lithium, 2 phosphates, 3 zincs, and 1 nitrate. Okay, so let's pick something else to start with. I want to pick phosphate, just because. All right, doesn't matter where you started. It might take you a little longer back and forth, but eventually you get this. We'll all get the same correct answer, right? So I want to multiply where I see phosphate on the left side by 2, so I get 2 on both sides, right? So they got to balance out. All right, so where does phosphate show up? It shows up there, so I need to put a 2 there in the coefficient. All right, now that's going to multiply the lithium as well by 2, and we have 3 of them. Need to multiply that by 2. We got 6. All right, phosphates are good. Let's go to the right, multiply where we see lithium by 6 to balance that. All right, so put that 6 there. We need to update that nitrate now, also by 6. All right, let's go to the nitrate now. Left side, we need to multiply that by 3 to get 6. All right, put that 3 where you see the nitrate. That's where you see it. Put the 3 there. All right, it's going to update the zinc, and hopefully, yes, we're done. All right, so that one wasn't the, normally they're a little easier than that. Okay, 2, 3, 6, 1. Now we can write our complete ionic equation is what it's asking us to do. All right, so this complete ion means charges, so that's probably the most common thing students missed is they didn't put charges. You got to put your charges everywhere you see AQ. These are not just compounds anymore. Once they hit that water, they're gonna dissolve. All right, so I'm just breaking them apart into their charges. All right, I've got 6 lithiums. All right, 2 times 3 is 6. All right, that's a positive charge. That's right off your periodic table. All right, and that's now dissolved in water. Phosphate. All right, I've got 2 phosphates, PO4. That's on your reference sheet. 3 negative charge. Again, every ion has to have a charge. All right, this part in red is what you're getting graded on. It's what you're supposed to. This is your answer. All right, and so this one is also aqueous. So there's 3 zincs. All right, zinc has a 2 positive charge, AQ. All right, and then we have 6 nitrates, NO3, 1 negative charge, AQ. All right, arrow. All right. This is also aqueous. I'm going to break that apart. There's 6 lithiums. Lithium has 1 positive charge when it's an ion, and then there's 6 nitrates. Nitrate has a 1 negative charge, and all right, this one is not aqueous. It's not soluble, so it doesn't dissolve. That's what that S stands for. It's a solid. So we're going to write that just the way it is. Solids do not have these compounds don't have charges. They're neutral. So we're just going to write that exactly the way it is. All right. Only ions have charges. All right. So there's you got most of your points for getting this stuff here in red. All right. Now you cross out the spectators. What do you see on both sides? All right. That's a spectator. It's the same before and after the arrow. Didn't do anything. He just went to the party and watched. A spectator. All right, and so was a nitrate. Didn't do anything. All right, went to the dance, just watched. Okay, junior prom Saturday. Speaking of dances. All right, so whatever's left, that's your net ionic equation. So that's part B. That's going to be your answer. Just write whatever you see. Just copying what's left. Nice job to all the students that got this. It's very nice. There's a lot of steps to this one. Okay, so the atoms are you can balance it yourself. The atoms are balanced. The charges are balanced. All right, there's no charge on either side, net charge at least. So there's your answer to part B in green. All right, let's move on. This one, if that looks familiar, it's because it was copied from your simulation. Remember this? I think it was a level 2 question. It wasn't even level 3. All right. Anyway, if you did that in class, when I asked you to do that in class, then you have experience with this. So let me go over this with you anyway. All right. There's a fluorine on the left. There's a hydrogen and there's an oxygen. There's 2 of those. There's 2 of those, and there's 1 of those. All right. In the same order. All right. There's 2 of those. There's all right. Level 2s can be kind of tricky too. All right, fluorine appears twice, so I need a separate line for each of those. Okay. Otherwise, I'll try to keep it in the same order as the left side, so they're kind of side by side. All right, so there's 2 fluorines for that one. All right, there's 1 there. There's 1 hydrogen and there's 1 oxygen. All right, so what is not balanced? What do you want to do first? Let's do hydrogen first. All right, multiply that by 2 to get 2 H's on both sides. All right, that thing has to go there. All right, that's the only place you see that H. Multiply. Also update that F, which is this one right here. All right, so we got a total of 4 Fs, 4 fluorines on the right side. All right, so we'll do the fluorine last because that's the most easily manipulated. It's all by itself. Let's take care of this oxygen. Oh, oxygen are good. Oxygens are good. All right, so fluorine times what will give you 4. That's 2. Everything is balanced. Put that there, and these are 1s. All right, we don't write 1s, but I asked you to write it. So I knew you weren't getting credit just for skipping an answer. Okay, this one is just, I think I copied this from your lab also. Can I go down just a little bit? There we go. All right. Magnesium, we burned this in station 7. Those were those ribbons. I told you not to look at it, not directly at the light. So this is a combustion reaction. It burns and gives off energy, a lot of heat. All right, so write the balanced equation. So this is in the format A plus B, right? So A plus B. What can happen other than for them to combine into AB? All right, so let's do it. Let's combine them. right? Now the cations are written first, so I'm going to put Mg, magnesium first, and then oxygen. Now, did you do that? I already know a lot of you did that because I already graded your test. And at the beginning of the lesson, I told you this is the most common thing students do wrong, and I try to make that very clear. Put it in red. Yep, you did it. A lot of you did it. Don't carry over subscripts. Right? You've got to get the charges and use those charges to get the formula. You never just see a 2 there and bring it over. And it's okay. All right, so these charges are going to cancel out. So there's your formula for magnesium oxide, and notice that's an ionic compound that has a high melting point, so that's a solid. You may have lost half a point if you put something else there. Okay, let's balance this. All right, we have 2 oxygens on the left side, so we're going to need a 2 there. All right, now we have 2 magnesiums on the right side, so we're going to need a 2 there. So there's your balance equation. Now, what part B? What undergoes oxidation? What undergoes reduction? Oxidation. Let me put this in some colors here. All right, Leo the lion. What does Leo do? Grrr. All right, Leo the lion goes grrr. All right, so there's your mnemonic. Loss of electrons is oxidation. Which one is losing electrons? All right, well, magnesium is the cation. Right, let's draw the electrons on here. All right, magnesium is the metal, oxygen is the non-metal. I just drew the valence electron. All right, so we learned in chapter 7, right, metals transfer electrons to non-metals. All right, so magnesium is losing electrons, so magnesium is oxidized. All right, magnesium is Leo, right, oxidized. Which, well, if something is losing electrons, something else is gaining those electrons. Gaining of electrons is called reduction. Grrr. What's gaining those electrons? All right, well, oxygen had 6. It wants to get 8. It's called that octet rule. It's gaining them from magnesium. So oxygen is reduced. These are called redox reactions, by the way. All right. Got to move faster because my lunch is almost over. Complete and balanced equation for the reaction. Nothing's going to happen. Silver. All right, so silver is a precious metal, so is gold. These things, if they were very reactive, they wouldn't be very good jewelry things, right? So they're inert. They don't react very well. So that's why they're used for jewelry. And all right, if you look on your activity series, silver is all the way at the bottom. It's not going to replace anything. It's not very reactive. And potassium is an alkali metal. It's one of the most reactive elements. It's way up here. Like lithium's up there, potassium's up there, and silver's not going to replace any of those things. So the answer here is simply no reaction. No, nothing's going to happen. That silver is just going to sit in that bottom of that beaker with the silver nitrate, and just you can watch that beaker all day and nothing's going to happen. All right, part A of your next one. Now this one, something is going to happen because anything is going to replace silver except for gold. That's even less reactive, but zinc is going to replace silver, so let's write this out. All right, go faster. Zinc, metal, and a solution of silver nitrate. Zinc, metal, solid. Silver is Ag. Nitrate is NO3. That's a 1 negative, 1 positive charge. That's on your reference sheet. That's on your reference sheet. Okay. They're going to cancel out. Put AQ here for solution. All right. I already told you this is going to replace that. All right. Silver is very unreactive. Zinc is. So, hey, you want to make pure silver? They're pretty valuable. This is what you do. You can, although this would cost a lot too. All right, so silver is going to get displaced as a solid. Call that a precipitate. And zinc is now going to be with nitrate. All right, so we're going to need parentheses here because nitrate has a 1 negative charge and zinc has a 2 positive charge. That's going to come out there. All right, so all nitrates are soluble. That's on your solubility reference sheet. Okay, so we've written, completed the equation. We just got to balance it. Let's do that. Says about, no, we need 2 there, right, to make it 2 nitrates on both sides. All right, and then now we need a 2 there to get silver on balance. There's your answer to part A. What is oxidized, what is reduced? Now it's easier to see if you break this apart into their ions. All right, so let me just write this here. Zinc plus, this is going to be, AQ, AQ. They're going to dissolve in water, so it's that they're actually not in these compound forms. It's more accurate to say, this is silver with a 1 positive charge, all right, plus nitrates and with a 1 negative charge, and this is going to stay the same. 2 positive, 1 negative. Okay, so if you do that, you can eliminate the spectators. All right, so these are spectators. They don't do anything. So now you're down to 2 choices. Well, they have to be your answer because there's only 2 left. All right, so in order for zinc to become positive, it must have what? Did it gain negative charges? No, of course not. Wait, what did I just say? It lost negative. All right, so this is Leo. Leo. All right, zinc oxidized. All right, it lost electrons. That's why it became positive. All right, what happened to silver? Well, silver was positive. Now it's neutral. It must have gained electrons. So silver is reduced. Okay, we've got to move on. All right. Oh, all right. This looks like your textbook because I can tell the background. What is true about the chemical reaction? More that would violate the conservation of mass. If it required heat, you would see the word heat or that delta symbol there. You don't. It involves a catalyst. All right. Platinum is I told you when I used the example of catalytic converters, and platinum is just a very common catalyst in chemistry. So here's your answer. All right, and it's written over the arrow, and then this would violate the law of conservation of mass as well. Okay, this is A plus B turning into AB. Right, so that's combination, also known as synthesis. All right, this is Adam and Barb going to the dance. Xavier, Yasmin going to the dance. Them switching partners. Right, so that's what's going on here. I'll put the cations in red and the anions in blue. All right, they just switch partners. Okay, so all right, Adam went home with Yasmin, and then Xavier went home with Barb. But as you know, that's not the true story, right? Because we learned about net ionic equations. So that's a double replacement. Again, people bringing over subscripts, the most common mistake students make. Okay, so what decomposes to form this? So that's on the right side of the arrow. Right, well, it's only has, there's only 2 elements, so it has to be K and I together. Now, did you do that? I know a lot of you did that because that's what I see every year. Again, you got to use the charges, crisscross those charges, and they're going to cancel out. So there's your answer. This. All right. These are always a little challenging. These are from like the little more challenging section of your textbook, where your textbook comes with like a test bank. So, all right, let's just go through this. What's true? Total mass must equal products must. That's true. That is true. Total volume must equal the total volume. No, not necessarily. That's not true. But use red. No, I mean this. Do I have time for an example? All right. Well, think about this. I'll use the same example. No, I'll use the. All right. H2. plus O2 gives you H2O. All right, let's just say these are all gases. Well, this is happening at a high temperature. In fact, it might even go the other way. Yeah. All right, all gases. So we're talking about volumes here of gases. All right, if you balance this, okay, you're going to get a 2 there and a 2 there. All right. So you got 3 moles of gas in the reactants and 2 moles of gas in the product. So you already know, like, you're going to start off with way more volume and you're going to get less in this reaction. So statement number 2 is not true. All right, number of atoms must equal the number of atoms. Yes, that's conserving mass. That's why we balance equations. That's the whole point of that. There it is. We're done. All right, students, if you have any questions, I told you I'd give you a rubric, but sorry, I forgot about that. But anyway, if you have any questions about how your test was graded or perhaps anything, let me know.